Network model and layering. What are the processes required to prepare data for transmission on a channel? The network model contains layers that perform functions sequentially to get data ready to be transmitted along a channel. The communication process, the process of moving data from an application onto the channel, is layered or divided into multiple smaller processes. Each process accomplishes a specific set of functions. Data moves from one process to the next until it becomes signals and gets onto the channel. There are 7 layers described using the OSI reference model. Each layer has a specific function to perform. Layer 7, the upper layer, is the application layer. Layer 6 is the presentation layer, Layer 5 session layer, and so on. Layer 1 is the bottommost one, is the physical layer. So data actually comes from the application, goes into the application layer, gets processed, moves on to the presentation layer, gets processed there too, and moves on to the session, and then on to transport, network, data link, and physical layer. In each layer, the data gets processed as it moves down the OSI model. There is another reference model called the 4-layer Internet model. This is commonly seen in data communications. Here, the application layer consists of layers 7, 6, and 5 of the OSI model. So the application, the presentation, and the sessions layer of the 7-layer OSI model is condensed to form the application layer of the 4-layer Internet model. Similarly, the data link and the physical layers of the 7-layer OSI model is condensed to form the network access layer of the 4-layer Internet model. In each layer, there may be several protocols for various applications. For example, the HTTP protocol that helps you fetch web pages from the web operates on the application layer. The FTP protocol is a file transfer protocol that also operates on the application layer. The IP protocol, which is used in forming packets in the internet, operate in the internet layer. Each layer in the OSI Internet model adds a header containing structured information to the data received from the previous layer. This process of adding headers to data units obtained from the upper layer is called encapsulation. For example, look at how headers are appended to a typical voice over IP application in the figure. The data payload is produced by the application layer. This data payload is appended with a 12-byte sessions layer header using a protocol designed for voice over IP called real-time protocol, or the RTP protocol. The RTP protocol produces what is known as an RTP packet at the session layer. Then the RTP packet is encapsulated with an 8-byte header from the transport layer, as shown by the green colored header besides the RTP packet. The header structure for the transport layer is prescribed by the UDP protocol operating in the transport layer. The UDP packet then goes to the network layer that appends or encapsulates a 20-byte header using the IP protocol to produce what is known as the IP packet. And the IP packet eventually gets a 26-byte header from the MAC protocol at the data link layer. So by the time data payload enters the channel, it is successively encapsulated with protocol-specific headers at each layer. At the other end of the transmission, the reverse operation takes place. Each layer receives data unit from the lower layer and successively removes the header for that layer, and ultimately the data payload is received by the application layer. This figure shows encapsulation at each layer. You will notice that not all nodes in a network do or perform operations at all the layers. For example, the end nodes perform all the layered operations, starting from the application all the way down to the physical layer. And at each layer, they encapsulate the data unit received from the previous layer. However, you will notice in the figure that a router, which is an intermediate device that performs routing operations, does only the lower layers. It does not do the transport or the application layer. Rather, it does only the internet layer on which the IP protocol runs and the lower layer protocols. And you will also notice that in a router, the lower layer protocol, the network access layer, can do more than one protocol function, one for each link. So you see there is frame relay protocol for the incoming link, and there is the LLC and MAC protocol for the outgoing link. We will see more details of a router when we cover network layer. Also note that each layer has what is known as a peering relationship with the same layer in the other device. This relationship is not a direct connection from one end node to another end node and at the same layer. Rather, what happens is that each layer in an end device will keep track of the same layer operation in the other interconnected devices. For example, application layer or the TCP layer in the end node will keep track of the application layer and TCP layer specific information of the other end node during data transfer. Thus, we see that network models have layering of functions. Each layer appends protocol-specific headers to the data unit received from the previous layer. Each layer also strips the header while receiving data units from the lower layer.